Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Last time, we started on our entity component system, still not to be confused with a system of entities and components, and the terminology is still terrible, but I digress. We created the component, and it took a whole bunch of finagling because we need runtime dynamic types. But that's okay. At the end of the day, we can create components really easily. Just inherit from the class and create like it's a C-struct. Boom, done, all taken care of, no fancy handling needed. Really easy to use, a little bit tricky to implement, which is really what we want. But that's just one part of this. As the name implies, we still need entities and we still need systems. How do we do that? That will be the topic of this video. Let's go. So, our first task, we're going to do the systems because they're really easy. So, ECS system.hpp, we're going to go in, we're actually going to close ECS component, we don't need it anymore. Paragmo once, and we're going to include our previous class, I can spell include, there we go, ECS component.hpp. We're going to need to know about components to do this properly. Other than that, though, the class is going to be really easy. It's going to be ECS system, and actually, base ECS system. We're going to follow a similar paradigm. And yeah, public and private, which Vim wants to auto-indent for unclear reasons. But that's okay. So, the key feature of this class is going to be a virtual method, to be void, called update components. Because if you remember from our diagram in the last video, all a system does is it takes a certain set of components and it updates every entity that has that set of components. So we're going to take a base ECS component double pointer for the components, and we're not going to have any implementation. The other thing, though, is we're going to take in a float delta for the same reason you have a delta in really any other update function. This tells us how much time has passed since the last update. And yeah, there you go. That's pretty much all it's going to have. The only other thing is we are going to need to know, hey, what set of components is this particular system working with? So to do that, I'm going to have an array of uint32. It's going to be called component types. There you go. And it's going to work exactly how you think. This will tell us how many component types we have, and the uint32 will be the component type ID, like we specified in ECS component.h. Everything has its own ID. So that'll be really nice. That'll let us know at runtime, hey, what components are we working with, and how should we treat them? So other than that, yeah, I pretty much just need a constructor, base ECS system. We're just going to take in, I'll just take in a const array of uint32. It's going to pass by reference, call it component types in. Just going to work exactly how you expect, going to initialize component types with the component types in. Boom. And last but certainly not least, we are also going to want to be able to know what component types this base ECS system is working with, so that we can pass it, the right components. So yeah, I'll take a const array of uint32 reference for us. I'll just call it get component types. I'm not going to do anything particularly fancy here. And yeah, it's just going to return component types. There you go. All done. This is all we need in an ECS system for now. You might imagine this is going to be a little bit, how should I say, bulky syntax when we actually go to implementing it in practice. If we want to implement, say, a rendering system, we're going to have to initialize this array manually. It's going to be a little annoying. But, oh well. We'll cross that bridge when we get to it. For now, we're just going to have the raw base system, and we'll worry about the syntactic sugar later on. So, with that, all we have left are the entities. And since an entity is literally just a list of components, I think at this point it makes sense to finish off the dynamic type system of the components. So, in the last video, we pretty much added all the elements of the system. All the pieces of this are in place. all we're missing is the key data structure that makes it all work. The key thing that lets us know, given just an ID for the type of the ECS component, how do we create it? How can we free it? What is its size? How can we essentially look up all the parameters of a given component type knowing only its ID? That is what we're going to create right now. So what we're going to be doing is we're going to be changing our next ID function. We're going to change this to register component type. And as you can imagine, this is going to take in a create function. I'm going to call it create, and I'm going to add fn, mainly because right here I'm going to call it free, and I want that to distinguish from the free actual function in the C memory library. And yeah, so and size t size. So this is everything. I'm going to add new lines so it's a little bit nicer format. And there we go. We're also now going to need a private member of this. We're going to have a private static array of tuples. And the tuple, as you might be able to guess, is going to be the create function, the free function, and the size. So, yeah, this is, I'm going to call this, component types. And yeah, this is how it's going to work. We're going to be able to look in this array at a given index to know, oh hey, this is that component type, and this is the create function or free function or size or whatever, knowing just the ID. So of course we're going to need to change our implementation to work with this. I'm going to rename next ID to all this. And there we go. It takes in the new parameters. We can get rid of our global variable now. Though technically it's just replaced by another even worse global variable, because now this one does dynamic memory management in global scope, which is not the worst thing in the world, but it adds some complications. But anyways, we can always do this a little bit better, just like before, just like we're doing right now, so I'm not too worried about that. So first off, our ID is just going to be, if I can ever type it, this is just going to be component type dot size. There we go. And we're going to return this at the end. And all this function is going to have to do is just going to have to add whatever type we're registering to this. So component types dot pushback. Yeah, a new tuple. Just going to copy all this because templating gets a little verbose, but that's okay. And on a new line, we're just going to add create function, free function, and size. There we go. Now we have a global index of all the component types. At runtime, I can look up by ID what the appropriate create and free and size functions are for the component, or any other per component type data that I might care about later. So that's really nice. We just need the functions to access this now, and we will be good to go. So this is going to be pretty much just inline getters. They're going to be pretty much syntactic sugar for all of this stuff. So I'm going to start by just inline static ECS create function, get type create function, and it's going to take in the ID. And guess what it's going to return? We're going to return std get element 0. This is how you access a tuple. And we're going to pass in component types, ID. So this is how it works. We're going to get the tuple for the ID, and this gets us element 0, aka the create function. So there we go. Now we have an easy way to access it, and the rest of the program doesn't have to care how we're doing this internally. We can easily change it and modify it later. So function, same thing, except element 1. And you'll never guess how we're going to do the last one. So we're going to take in get type size, and it's going to be, you guessed it, number 2. And that's really all there is to this, other than the fact that where we have next ID, we're now going to need to specify register component type. And it's going to have to take in all of the stuff. So, since I'm not sure there's a guarantee of order for how this is going to do, I'm going to do some slight code duplication here. So we're going to specify the create function of t, the the free function of t, and the size of t. So it's not the nicest thing in the world because we have code duplication here. If for some reason we need to change one of these, we'll have to remember to change it here or the program will break. But on the plus side, now we're guaranteed that this will work regardless of the order these templates are instantiated in. So that's another way we can avoid the program break. It's a bit of a trade-off. I think this is the lesser of the two evils. And yeah, that should be all we need for our component type system. But before we move on, let's fix the compiler errors. So, in ECS component.cpp, there's a slight typo. Component types is spelled wrong, as you see I've forgotten in. And we also forgot to initialize the component types array in here. So, you just have to add that in, pretty much copy and paste, remove the static, add base ECS components, and a semicolon, you're good to go. In ECS component, we forgot a few things. Namely, we forgot to include tuple. That's important because we're using them. And we also here, ECS create function. Yeah, what's supposed to be ECS free function, I still had an ECS create function. Just make sure you have that. And that appears to be everything, unless I forgot something, but I don't think so. So that should be all the compiler errors. So, with that, now we're going to go and create sort of the central system, the glue that makes all these things work together smoothly, our ECS class. So, it's going to be pragma once, it's going to be a class, of course, and of course I'm going to call it ECS. So, I think I'm going to start by just getting all the includes right, so I'm going to include, what should I include? Obviously, we need to know about the ECS component, and we need to know about the ECS system, and we're also going to need to know about data structures / map.hpp. Oops. I think that's about it. So, we have our ECS data structure. This is going to need to know about the entities, components, and systems, and make them all play together nicely. So I'm going to start with the data. What data do we need for this? In order of increasing insanity, our first data is going to be an array of base ECS component or system pointer. Yeah, that sounds about right. And that's going to be our systems. That's how we're representing our systems. Our next, we're going to do components. And that will be a map of our ID. And for each ID, we're going to have a separate array for each component. And this got to be a uint8 because all of them is a different type. And we don't know specifically what type that is at runtime. So we're just going to have a flat uint8 array to handle all that. And we're going to need some fancy logic and casting to make sure that all works out. Which fortunately, a lot of that is handled automatically by our dynamic type system. So this won't be quite as terrible as it might seem at first. And last, but most certainly not least, we're going to have our entities, which is going to be an array of pairs of integers, the integer being the index of this pair in the array, which might sound weird, and is a bit weird, I'll just go out and say it, it's weird. But the reason we're doing this is it lets us remove elements from the array really efficiently. And you'll see that, maybe not in this video, but soon enough. As for the entity itself, well, as I said in the last video, all an entity is it's just a list of components. Nothing more, nothing less. So we're going to have an array, and this is going to be an array of pairs, because we need the ID, the component type. So we know what type of component, and we're also actually going to refer to the component by index. So, yeah, we could have something like, say, base ECS component pointer. That's a valid way to do it. I'm going to prefer to do it with an index into the components array, so we can look up which array is the type, and this will give us which index in this array is that a component. It's just an alternate way to do it that I think works out a little bit nicer. And that's going to close the pair. This is going to close the array. These are our entities. Almost. The one difference is we're actually not going to refer to these pairs directly. We're going to refer to these pairs by pointer. The reason we're going to do that is so we can easily shuffle around all the entities in this list, and any reference to a given entity will still be valid. So that's why we're doing that. And this is it. This is our key data. So I'm going to add, at this point, because our entities are a little bit complicated, I'm going to add a few just utility methods to help us work with it. So I'm going to add inline. I'm going to call it handle to raw type. And this is going to take in an entity handle. I'm going to call it handle. And yeah, this is just going to be an easy way to go from an entity handle to this type. In this case, since they're both pointers, it's literally, well, first off, it's going to return this type, and it's just going to be a cast of the handle to this type. Again, the reason we're doing this is entity handle is supposed to be opaque. We don't know if entity handle is actually a pointer, an index into an array, or something else. So this gives us a way to work with handles from that opaque view. And if we want to change how entity handles are handled internally, we can do that. We just need to change this method, so that's really nice. Other than that, we want two more utility methods for the handles. We want inline, it's going to be a reference to an array of pairs. So yeah, an array of pair reference. And that's going to be called handle to entity. Because that's really what the entity is. The rest of it's just maintenance. So it takes in an entity handle. And it's going to return handle to raw type handle. And that will give us a pair, so I'm going to return the second part of the pair, which should be this array, which is what we want. And just one more thing, I'm going to say one more time, handle to entity index, which is just going to return a uint32, and that will be its index in this array of entities, which is the first element of the pair. So there we go. Now we have all utility methods for working with entities. So I just did the compile test, and we have a couple of small typos. Basically, I just forgot one extra closing bracket right before the pointer in all these types. So just make sure that's there, and then this should compile. So now, let's set up the public interface for our class. We're going to have ECS, nothing. We're not going to have anything in particular in the constructor. However, we are going to need a destructor for a couple of reasons. Well, first off, no destructor, that would be very bad. For one, we're manually managing the memory of the components because they're all dynamic, so yeah, we're going to need to make sure all of the create and free functions for components are called properly. We're also going to be dynamically allocating and removing entities simply so that we can shuffle them around a bit. Which, by the way, I forgot to mention, the reason we're having entities as part of the ECS class rather than their own dedicated class, actually that goes back to the fact that, really, if you think about it, like I said, components, raw data, they're nice, easy to isolate. They can be their own class. Systems, raw logic, nice, easy to isolate. They can be their own class. Entities, there's kind of like the bridge in between them. They tie components together, and systems need to interact with them properly, so you might be able to get away with making them their own class, but I've found it makes the code a lot easier if the ECS just manages the entities in their entirety. So that's why that is. So anyways, now we're going to have the methods for everything. So we're going to have, of course, a makeEntity method. This is because, well, like I said, ECS manages entities. It's going to take base component array, so which in this case is pointer. These are going to be the components attached to the entity. It's going to take in the number of components. Well, actually, first before that, a uint32 pointer, const uint32 pointer, called component IDs. These are all the types of components being added. And last but certainly not least, a size t for num components. This is going to be our basic raw entity constructor. We can add more later for syntactic sugar, but that's the raw way of doing it. I also want to be able to remove entities, so remove entity removes it from the system and deletes it entirely, so entity handle. There we go. And these are our entity methods. In fact, that's a good designation. So I'll have component methods, there we go, and system methods. I'm going to do system methods next, actually. I think that's nice. So I'm going to have void add system. It's going to take in a ECS system, a base ECS system. There we go. A base ECS system reference, if I can ever type today, my word. System, there we go. In fact, let's go ahead and just implement this, because this is going to be really, really straightforward. It's literally going to be system... No. What did I even just paste? Hang on, what did I just... Okay, apparently I copied that at some point, maybe? I don't understand what just happened, but apparently I'm just having keyboard malfunction, so... Excuse me. But yeah, it's very simple. We're just going to push back the system. And that's all we need to do. We also need remove... Do we need to remove systems? I'll go ahead and add it. Why not? I'll just leave that in comments. I'm not entirely sure if we even need that. But I do know we need a void update systems. And this is going to take in the delta of how long it was since we last updated the systems. So that's that. And last, but most certainly not least, we have components. What are we doing here? Well, as before, we're going to want to be able to add components to an entity, taking the entity handle entity. And I'll just leave it at that for a moment, just so I can quickly type out the names. I want to type out the names. Remove component and get component. Everything's going to be in relation to an entity. Also, these are going to be templated. So I'm going to have template. I'm going to take class. Sure, I'll call it component. And yes, so it's also going to take in... Oh, actually, this won't need a component in this case. So that's just going to work just fine. I'm going to be able to get component. Yeah, like that, okay. But add component, I will need a component pointer for the component. And for remove component, we're also going to need a template. And we're not going to need any extra parameters, because just knowing the type of component will be enough to successfully remove it. And with that, I think I am going to add remove system, come to think of it. We're just going to need the base ECS system reference for the system. Whoops. And that should be that. So now we have the methods written for everything, and also, very important, remember the null, copy, and assign for ECS. This is just something to have until we feel like implementing a copy and assignment constructor explicitly. So that pretty much fleshes out what the public interface for our ECS system is going to be. But that's a lot of methods, and there's some tricky logic and data structures going on here. How could you implement this? How could you get it all working nice and smoothly, really efficiently, and have nice simple syntax at the end? Find out next time! I hope you enjoyed, I hope you learned, and I will see you in the next video. But first, a couple of small typos. Under make entity, base component should be base ECS component, of course. Base component does not exist. And under add system, we need to push back the address of the system. Why? Because we're storing the systems by pointer. And that should be everything. If you're interested in talking more with me or other like-minded people, consider joining the Benny Discord listed in the video description. It is a fantastic community, everyone is welcome, and yeah, it's a great time, just come hang out. If you're interested in supporting these videos, or you just want to find out right now, consider becoming a patron on Patreon. You can get early access to videos, special roles on Discord, bonus video materials and reference materials, and you could even get special thanks. Thank you very much to all my patrons. You all make these videos possible. And a very special thank you to those listed in the video description. Thank you very much. See you next time.